Okay, so cathane stuff. I want that goo. I really need those solar panels. Don't care too much about the generators. Although that would be nice. There's 750. Yeah, just over 1,000. Bigger docking port. I might actually use docking ports and structural parts, so I'm going to get that. Surface mounted air brake, which would be very useful, but I need more communication satellites, especially this one. And then what's this? It's only 100. Okay, we're definitely going to get Mars 1 and Verena 1. I think that's how you say that. Verena 2 and Mars 2 don't have anything in them.
Venera 1, also known as Sputnik 8, was the first spacecraft to fly past Venus.
Is that 50? No, that's 250. I'm going to go for the extendable solar panels. And then what's next? More extendable solar panels. I'm definitely going to get the engines. And decisions. I think I'll go with Gemini 1. Oh yeah, we should probably get life support. And radial parachutes. Those will be useful. And what's that? Procedural life support tank and procedural heat shield. Yes. So now, yeah, we get one more antenna. And what's that? Another antenna. I left out the goo canister. Oh well.
The first launch of Episode 8 will be an operational test of our standardized launch system, the Athena 1A. It is a triple-stage launch vehicle with a monopropellant attitude control system on the second and third stage. The first stage not needing attitude control beyond the engine's 2-degree gimbal. Its primary use will be payloads of up to 10 tons to low Earth orbit. It is also capable of putting almost 1 ton in a geostationary orbit. There are 3 variants of the first stage. The A variant is an O2 with 310 kilonewtons of thrust and a specific impulse just above 280 seconds at launch. It burns kerosene and liquid oxygen and has an alternator that generates 4 amp-hours of electricity per second. I would like to cover a brief explanation of ISP before the second stage separation. Specific impulse. What is it? You may have heard it's a measure of the efficiency of an engine, which is correct. But to be more precise, it is the rate of conversion from mass or weight to momentum. Notice how I said mass or weight. That is because there are 2 different ways to calculate ISP. If you calculate using mass, which is a unit of speed, then specific impulse is measured in meters per second. However, if you instead calculate specific impulse by weight, then your result will be measured in seconds. This is the more common unit used to measure ISP, and the one KSP uses. When building a rocket, it is a good thing to keep in mind that while higher ISP is better, if you are using a fuel that occupies a larger volume, its tank will be larger, likely making your rocket heavier, and therefore your total delta V will drop. Which is why a high-density fuel is almost always preferable. The weight of the engine itself is also something to keep in mind. Of course, fuel volume to weight ratios aren't something that stock KSP players have to be concerned with. Instead, it is the Real Fuels mod that adds this complexity. As an added aesthetic to this launcher, we have added lights on each stage. The first stage is red, the second is green, and the third is blue. For the second stage, we have chosen the LR47, which is an American plug nozzle aerospike. It is restartable and deeply throttleable. It has only half a degree gimbal, which is why we need the attitude control system. The LR47 has a maximum thrust of 700 kilonewtons, an ISP of 335 seconds in a vacuum, and uses the same type of fuel as our first stage, kerosene and liquid oxygen. Gimbal, or possibly better known as thrust vectoring, is, as it implies, changing the vector at which the thrust is being applied, effectively changing the direction at which the streaming jet of hot gas is leaving the rocket, which in turn gives the rocket the ability to change its course. The gimbaling ability of a rocket engine is measured in degrees, some engines not having a gimbal, some barely being able to turn 1/10 of a degree, with the highest gimbaling ability of a rocket engine being around 12 degrees. A side note, if you are playing KSP with a keyboard, avoid a gimbal above 8 degrees for a traditional rocket. Any slight wobble will be amplified by SAS, and manually trying to regain control of the rocket with a jump from 0 to 8 degrees can cause even greater problems. One of the abilities of the second and third stage is real-time monitoring via a camera mounted just above the respective engines. The third stage is an A9R, again using kerosene and liquid oxygen. It has a specific impulse of 336 seconds and a max thrust of 58 kilonewtons. In 1946, the unit of force was standardized to be that amount needed to accelerate 1 kilogram, 2.2 pounds, at 1 meter per second, 2.24 miles per hour, per second. It was named the Newton. One kilonewton is enough to accelerate 1 million grams, 2,205 pounds, at 1 meter per second, or 1 kilogram at 1 kilometer per second, per second. The first stage of the Athena 1A, with 3,100 kilonewtons, has enough thrust to add 12 meters per second to our launch vehicle's velocity per second. So by now you've listened to me talk all about the launch vehicle, and I also defined some terms that you should probably know if you're playing KSP or just generally interested in rocket science. But you're probably wondering, what are we launching? Where is it going? And what's the objective? So allow me to answer my own proposed questions. Magnetometer. High elliptical orbit over Earth. to map the magnetic field of the planet. So this will be something that is going to be really important later in our career. As for now, it's just more data that we can add to the pile. The probe itself has a lot of delta V because we will be altering its orbit quite a bit before we finally put it in a circularized orbit at the optimal height, which we haven't figured out yet. We will get there. But anyways, we will save that for later. For now, it will stay in an 820 megameter by 200 kilometer orbit until we can get some science data from it. Spacecraft magnetometers have mostly been used for scientific investigations and attitude sensing. Explorer 1's magnetometer confirmed the existence of the Van Allen radiation belts. Magnetometers have also detailed the magnetic fields of Earth, the Moon, Sun, Mars, and Venus. Moving right along, this is Athena 1B+. It has a 3-part first stage, which is the only thing that has changed. 2 drop tanks were added, powered by LR-69s. The LR-69 is an American engine. It was the first large, lower stage hydrolox engine, meaning it is fueled by mixing H2 with oxygen. That's making water. It produces 1,912 kilonewtons of thrust and has a specific impulse of 337 seconds at sea level. It can gimbal up to 3 degrees, and its alternator produces 12 amp hours of electricity per second. Another thing that we've added to the first stage are the solid rocket boosters, which add an extra 9.3 tons each at launch. They have an ISP of 235 seconds and will burn for the first 32 seconds, producing an extra 588 kilonewtons each. I should make it clear that the Plus version adds the solid rockets. The Athena 1B does not have these boosters. There is one other variant of this launcher, the Athena 1A-, which has the third stage removed. Solid boosters are away. Everything is still nominal. We have tank separation. Everything's still nominal. I'm getting reports from ground observations that there was an explosion. I'm reading everything is still nominal, so we will continue. We have second stage separation. Second stage is lit. And everything is still in the green. It appears the hydrolox tanks succumbed to aerodynamic stress and were ripped apart. Most of the parachutes did successfully deploy, but the tanks will be scrap metal. We have third stage separation. We are just waiting for the ignition. The third stage has been lit, and we are on our way to the moon. LOREM is our payload for this launch. It stands for Lunar Low Resolution Mapping. It is a small probe that will double as a comms relay. Its destination is between 200 and 500 kilometers above the lunar surface. It is about the most simple probe you can get, a robotic nav computer capable of receiving and carrying out commands, a high and low gain antenna, a radar mapping dish, solar panel, and battery, and that's it. Lunar Orbiter 1 was the first probe to visually map the lunar surface. It also collected radiation and micrometeoroid impact data. A total of 42 high-resolution and 187 medium-resolution frames were taken, imaging about 5 million square kilometers of the Moon's surface during its 80-day mission. I'm going to save you from the long burn out to the moon and end this episode here. Thanks for watching. Click that like button if you would like to see more. I will talk to my computer more next week. This has been Grim, doing rocket science so you don't have to. До свидания.